know if Fz is analytic, domain D. This D is a domain. Okay, this is a domain. This is a domain D. If C is in this domain and C is open, this is the beginning point, this is the end point, this is C. We know if Fz is analytic in domain C, then this integral doesn't depend on the curve. Only depend on the beginning point and end point. So if Fz is analytic on this D and C is a curve in this domain, if C is open, so there is a beginning point and an end point. If this one is analytic, the integral doesn't depend on the curve, only depend on the end point and the beginning point. So if Fz is analytic, this is A, this is B. If you along this C or along another C, this is C1, this is C2, or this is C3. If this point and this point is the same, okay, CR, C1, this integral equal C2 equal C3. So now, for example, if this is Z square, this is dz, we know this C square is analytic on the all complex plane. So this is the beginning point, this is the end point. For any curve from this point to this point, this integral has not changed. This integral equal 1/3, 1 plus I 3 power. Like Z square dz is 1/z plus 3 power. Then Z from 0 to 1 plus I. So equal this one. But this Fz must be analytic. Okay, if Fz is analytic, this C is open. This integral doesn't depend on the curve, only depends on the beginning point and the end point. But if this C is not open, if this is a domain D, okay, and there is a curve, but this curve is not open. This curve is closed. If this curve is closed, this is the beginning point. Okay, from here to. So the end point and the beginning point is the same point. So if this C is closed, and this Fz is also analytic, the integral equal 0, because the beginning point and the end point is the same. So for another example, if you compute this is Z square, this C is the modulus of z is 1. If you compute this integral, because this function is analytic, so this is closed. Yes or no? This is closed. So the integral is 0. Is 0. For another example, this z is closed. The modulus of z is 4. Is true. This is sine z square dz. Because this function is analytic, this z is closed. So the integral is also 0. Is also 0. Is also 0. Understand that? So if this fz is analytic, if this c is closed, the integral is 0. If this c is not closed, is open, the integral doesn't depend on the curve, only depends on the begin point and the end point. Understand that?
So Laoshi, how do we know that integral is closed or is open?
See, the curve is open or is closed. How to know? It's very easy. For example, if you give me a curve like this one, this is open. But you give me a curve like this one, this is closed. So, if the curve is like this one, the modulus of z is 1. We know the modulus of z is 1. This is a circle. The circle center is 0. The circle radius is 1. So, this c is closed. Understand?
Yes.
So, in your book, okay, in your book, you can see 16, the 7 question. The 7 question. Okay? Let me see the 7 question. You can try it. You can try it first. Then I will teach you. Okay? 7. 1, 2, 3, 4. Okay? You try it first. Okay, give me. Okay. Tell me your answer.
Maybe because I think it's 0.
All is 0.
Maybe.
Yes, all is 0. Not maybe, yes. The first one is 0 because this C is closed. This function is not analytic anywhere, but is analytic inside this one. For example, we know the modulus of Z is a circle. Is a circle. Okay, this is C. But we know this is Fz. This Fz is analytic except what? Except this square plus 2z plus 4 is 0. Except this point. Yes or no? But if z square plus 2z plus 4 is 0, z equal what? Z equal 2 minus 2. This is I. This is 2. Yes or no? Remember?
Yeah.
This is what I have told you in the first class. Okay, so the last answer is minus 1 plus or minus I. Okay, so the first pointer, this is minus 1. This is 1. So the first pointer is here. The second pointer is minus 1. Is minus 1 is here. So these 2 points is not inside. So this function is analytic on this C and inside. Yes or no? So you can find a domain D. This is a domain D such that Fz is analytic in this domain and this closed curve C is inside this domain. So there are two conditions, and these two conditions satisfy. So the last answer is 0. Understand it? So if the first is understand, second and this all the same. Because this function is also not analytic if cosine z equals 0. But cosine z is 0. This z is k pi. You know k pi when k is k pi plus pi above 2. Yes or no? So when k is 0, the first point is pi above 2. Pi above 2 is more than 1. So all the point is outside, not inside. So this one is also 0. This one is analytic anywhere. Yes or no? This one is analytic everywhere. This one is analytic everywhere. So they are multiplied is also analytic everywhere. So 0. This one is the same. This is the modulus of z is 1/2. But this if equals 0, this equals 0. The modulus is 1. So 1 is more than 1/2. So all this point is not inside this, but outside. So it's also 0. 40. Can you understand it? You understand it?
But when can we have the response which is not 0?
So you must picture it.
Like for example, if we found out that the points are inside,
Yeah.
yet it is like this, can it give us 0?
Yeah. If C is closed and this function is analytic, and this C is inside, C and inside, the integral is 0. If it's not analytic, maybe not 0. So must be analytic of C and inside.
But if it is not analytic, what can happen?
What is analytic?
If
it's not analytic. If it's not analytic.
And it is closed like that.
Which one?
If it is not analytic and yet the integral is this one.
Okay.
Can also give 0.
For example, if the modulus of z is not 1, it's 2. And if the modulus of z is not 1, but it's 2, you know, this function is not analytic. Because cosine z equals 0, z equals this one. Yes or no? So you will see is the modulus of 2. This is 1, this is 2. This is c. So you know when k equals 0, pi above 2 is here. Yes or no? K equals 0. K equals 0, pi above 2 is here. So this point is inside. So this function is not analytic on C and inside. If it's not analytic, this integral maybe not 0. Now we will equal what? This is another knowledge, but this is not this knowledge. Okay, understand it? Yeah. But if it's not analytic, I also will tell you some kind of next time. Okay, next time. Today you learn this one. You learn it's analytic. Okay. If it's not analytic, I will tell you next time. Okay.
next week.
Next week. And all of you must come here on time.
Yeah.
Okay? Come here on time because we have a test. Okay? So today is over.